Dober dan in lep pozdrav vsem udeležencem. Dobrodošli na današnjem webinarju, kjer bomo govorili o uporabi biokompatibilnih materialov s tiskalniki Formlabs. Za začetek webinarja naj vam predstavim ekipo, ki je bo danes z vami. Z nami je Miloš Jovanovič, predstavnik podjetja Formlabs, ki se nam pridružuje iz Beograda. Torej, poleg njega je še Rok Vojska, moj sodelavec v podjetju IB-CADDY, ki je trenutno v Kamniku, in še moja malenkost, Rok Žabkar, prav tako seveda iz podjetja IB-CADDY, se vam oglašam iz Ljubljane. Če gremo naprej, bomo sedaj videli našo agendo, torej začeli bomo seveda z uvodom. Potem bo Rok predstavil produkte podjetja Formlabs, torej Form3B in Form3BL tiskalnika. Povedal bo, kako se postprocesira, kakšen je sam postopek tiskanja. Potem bo pa Miloš prevzel besedo in bo povedal nekaj o Formlabs biokompatibilnih materialih in aplikacijah, kjer se te materiali uporabljajo, plus povedal bo tudi, kako podjetje Formlabs pomaga v boju proti koronavirusu. Na koncu bomo seveda zaključili z vprašanji in odgovori. Naj samo na hitro predstavim naše podjetje, torej podjetje IB-CADDY je bilo ustanovljeno leta 1991 v Ljubljani. Torej v Ljubljani imamo še vedno sedež, s tem, da imamo pa tudi sedaj v Kamniku ITC oziroma izobraževalno-tehnološki center, kjer imamo tudi naš showroom z našimi 3D tiskalniki. Imamo pa tudi pisarno v Beogradu v Srbiji. Ukvarjamo se z široko paleto rešitev za industrijo, torej od CAD področja, kjer uporabljamo SolidWorks, z različnimi rešitvami, ki so vezane na to okolje. Torej ukvarjamo se tudi z softwarerskim razvojem, torej za posebne aplikacije. Imamo v naši ponudbi tudi 3D skenerje in seveda 3D tiskalnike, med katere seveda spada tudi Formlabs. Sedaj pa na hitro predajam besedo Milošu Jovanoviču, da nam predstavi v parih besedah podjetje Formlabs. Miloš.
Thanks, Rok. Thank you. So, welcome all. Warm welcome from my end. My name is Miloš. I've been working with Formlabs for over 3 years now. We just wanted to make a quick introduction on our end and to introduce the Formlabs and what we are doing. But later on, I will go a bit more into deep dive into application and what we are doing in the, let's say, healthcare and biocompatible materials. So I will leave that for later on. You can go to the next slide, please. Yeah. So just a brief history of development and growth of Formlabs. Most of you, if you know us already really good, then I don't have to go into details. For those who don't know us, we started in 2012, really humble. Max Lebowski, our founder, created basically a prototype in his basement and decided to share it on Kickstarter. It was a massive success. And then that kind of took it off. Instead of selling a couple of printers, we went for hundreds and then made the first iteration of Form 1 Plus. That really positioned us globally, and that is roughly the moment where I joined the company as well. And since then, we are just growing, and we are really focused on what we can do to customers, patients, and end applications. And basically, we are growing solely on the feedback that end customers are giving us in terms of we want to go there, we want to do this, I want to try to do this and that, and we just move it and take it from there. Last year we announced the Form3L, and later on in November, end of the year, we announced the Form3B, so SLA printer that prints biocompatible materials. But the main focus today would be the Form3L, the unit that is sitting behind the Rock that you can see on the screen, which is the biggest printer at the thanks, which is the biggest printer that we have at the moment. But on the company side, I mean, the numbers are there. Yes, we are significantly growing day by day, but what we are mostly proud of is that we are trying what is in our DNA, to democratize 3D printing. So it's really accessible and anyone can make anything. And this is to our core, just to allow people to really utilize the power of additive manufacturing and speed up whatever their application is. So that's all from my end for now.
Okay, thank you, Miloš. Torej, sedaj bom pa predal besedo mojemu kolegu Roku Vojski, ki nam bo predstavil produkte podjetja Formlabs, ki se lahko uporabljajo z biokompatibilnimi materiali. Torej, Rok, si z nami?
Ja, hvala.
Ok, Rok, če lahko kar prevzameš, jaz ti bom dal kontrolo nad mojim ekranom, tako da sedaj imaš.
Lep pozdrav še z moje strani, moje ime je tudi Rok. Kot je Rok omenil, jaz sem tudi v Kamniku, kjer v bistvu imamo tako rečen naš showroom, kjer te tiskalniki si lahko tudi v živo ogledamo. In v bistvu zdajle bom pa jaz predstavil Formlabs produkta Form 3B in Form 3BL. Kratica B v bistvu pomeni, črka B v bistvu pomeni kot biokompatibilna, se pravi te dva tiskalnika podpirata biokompatibilne materiale. Vse se pa, kar se tiče Form 3 družine, se pa vse začelo april leta 2019, kjer je v bistvu Formlabs preoblikoval že znano SLA tehnologijo 3D tiskanja v LFS tehnologijo oziroma Low Force Lithography. Že sama tehnologija je znana po tem, da so površine natisanih kosov izredno gladke, detajli so zelo izraziti, v bistvu lahko simuliramo vbrizgano plastiko. Tako da to je ta največja prednost te SLA LFS tehnologije v primerjavi z drugimi, kar pa je dodatno ta preoblikovana tehnologija, ki jo Formlabs zdaj imenuje LFS. Kaj pa ta doprinese, je pa v bistvu še bolj izraziti detajli, bistveno enostavnejšo, praktično minimalno vzdrževanje iz strani uporabnika. Samo servisiranje naprave je tudi se opravlja že lahko pri uporabniku na terenu, tako da ni treba vam vedno tiskalnik, bi rekel, pošiljati jih na popravila, ter tudi sama uspešnost samih printov je bistveno višja. Ter kar je tudi ta tehnologija doprinesla, da lahko Formlabs razvija nove, bolj zahtevne materiale, ki se iz samo SLA prejšnjo različico ni bilo možno, ter kar je še ta tehnologija omogočila, da lahko te svoje tiskalnike skelirajo v bistvu v velikosti, se pravi, smo s tem pridobili tudi večji tiskalnik kot je Form 3BL. Tukaj pa kratek posnetek v bistvu, kako ta tehnologija obratuje in v bistvu celotna optika, laser, vse, kar v bistvu utrjuje ta naš material, se nahaja v taki majhnem ohišju znotraj tiskalnika, ki je zaščiten pred zunanjimi vplivi, pred zunanjo umazanijo, ter je tudi zelo enostavno ga zamenjati v primeru, če pride do kakšne okvare. Tako da to v bistvu lahko že sam uporabnik naredi, ni treba vsakič, kot sem omenil, pošiljati tiskalnika serviserju in s tem v bistvu izgubljate na času. Tako da je to ena večjih prednosti tudi. Zdaj naš prvi tiskalnik, ki si ga bomo gledali, je Form 3B. Kot sem omenil, črka B pomeni biokompatibilni, se pravi, tiskalnik podpira popolnoma vse materiale, ki jih ponuja Formlabs, in je v bistvu v ta njegov delovno območje, v ta volumen že praktično spada že 80% modelov, ki jih v bistvu mi ljudje želimo tiskati. Ostalih 20% je pa prevelikih in jih je treba ali razrezati, ali pa jih tiskamo na kakšni večji tiskalnik. Trenutno, kakšna je rešitev za tiskanje večjih kosov, je, da je treba kose, kot sem menil, razrezati ali pa dajati ven drugim proizvajalcem, da nam naredi. Da bi pa to odpravili, pa Formlabs s to posodobljeno tehnologijo so lahko to volumen skelirali in smo s tem pridobili Form 3L in Form 3BL. Se pravi, Form 3BL je ponovno podpira biokompatibilne materiale. Trenutno stanje na samem trgu, kar se tiče visokoformatnih SLA tiskalnikov, je, da so večinoma ali so cenovno zelo ugodni, vendar s tem tudi slabša kvaliteta, ali so pa zelo dragi in seveda s tem tudi vrhunska kvaliteta. Tako da Formlabs s svojim Form 3BL spada ravno tam vmes za dostopno ceno, z še vedno zelo visoko kvaliteto. In tukaj imamo Form 3BL na desni strani, tukaj tudi za mano, in na levi pa je manjši Form 3BL kot za primerjavo. Spodaj pa tudi vidimo slike delovnih kosov naprintenih z maksimalnim delovnim volumenom. To imam tudi jaz, se pravi, tukaj na kameri lahko vidimo, tole je maksimalno delovno območje Form 3B tiskalnika, se pravi ta manjšega, ter večji volumen od Form 3BL, ki se nahaja za mano. Tako da v bistvu primerjava je delovno območje volumensko 5-krat večje, tako da s tem lahko natisnete bistveno več število kosov, pa tudi večje kose. Kaj v bistvu vse to doprinese velik tiskalnik, da ga imate vi pri sebi, tudi na splošno, če si prilastite tiskalnik? Prednosti so to, da do kosov pridete bistveno hitreje, kot če date delati zunanjim proizvajalcem, tudi bolje zanesljivo, saj ste vi tisti, ki ste pripravili kose, točno določili orientacijo in vse te priprave, tako da točno veste, kaj boste dobili ven, dokler ne prejmete od zunanjega proizvajalca, potem ne veste točno, kaj boste dobili, dokler te kosi ne prispejo do vas. Seveda z večjim formatnim tiskalnikom lahko tiskate že kose v naravni velikosti, ni vam jih treba skelirati oziroma samo razdelitev modelov lahko izločimo oziroma bistveno zmanjšamo. Ter, kar je še ena prednost Formlabs tiskalnikov nasploh, oziroma sploh te Form 3B in 3BL, isto LPO enoto, Formlabs konstantno posodablja kvaliteto tiskanja preko posodobitev programske opreme in s tem so printi čedalje hitrejši in kvalitetnejši. Sama uporaba Form 3 in Form 3BL je zelo enostavna. Sam zaslon na obeh tiskalnikih vas vodi skozi celotne korake, vam poda vse informacije, ki jih potrebujete za samo printanje, vas tudi opozori, če slučajno kakšen element manjka, če ste slučajno karkoli spregledali, vas tudi opozori na kakšna je obraba potrošnega materiala, če je že potrebno kaj zamenjati. Poleg tega beleži vse vaše printe in lahko v bistvu, kaj enkrat naložite na tiskalnik, lahko potem za nazaj eno in isto tiskate, ne potrebuje konstantne povezave z računalnikom. Sama uporaba tudi programa Preform, ki je od Formlabsa, je tudi zelo enostavna, praktično vam večina dela lahko pravi že samo, ko se vam ustrezno orientira, samodejno, lahko vam tudi samodejno generira podpore, ki so potrebne, ter kaj še dobra lastnost je, da vi konstantno lahko sledite, kako poteka samo tiskanje s tem, ko vzpostavite račun s tiskalnikom, to povežete in prejmete na mail ali telefon sporočila, obvestila, kako poteka samo tiskanje. Seveda pa Formlabs nudi tudi odlično podporo. Podpora tudi je možna v številnih paketih, ki s tem doprinesejo dodatne privilegije. Kot sem omenil, v bistvu tiskanje brez zamude v smislu, ker je vzdrževanje minimalno, ker je podpora strani Formlabsa zanesljiva, pa ker je tudi samo popravilo tiskalnika se lahko izvaja pri vas. To omogoča, da čimprejšnjo odpravo kakršnekoli napake, kakršnekoli težav in s tem lahko nazaj pričnete, nadaljujete z vašim tiskanjem. Tako da tiskalnik je dobesedno narejen na način, da deluje, da lahko printa konstantno in z zelo visoko uspešnostjo. Samo upravljanje z materiali pri obeh tiskalnikih Form 3 in Form 3BL je tudi enostavno. Materiali so kompatibilni z obemi različicami, ni posebej oblika za eno ali za drugo, ter so v obliki kartuš, ki se samodejno dozirajo notri v tiskalnik, tako da vi samo vstavite, kot pri navadnem tiskalniku, vstavite material notri, vam bom tudi kasneje demonstriral. In v bistvu to je to. Tiskalnik bo tudi samodejno beležil, koliko materiala je še v kartušah, tako da tudi sledite temu, ali imate dovolj materiala. Če slučajno zmanjka materiala med tiskanjem, se tiskalnik ustavi, bo na pauzi in bo počakal, dokler ne zamenjate material, dokler ne date novega in bo nadaljeval print, tako da ne bo se print prekinil, vendar samo začasno ustavi. Dobro. Zdaj si bomo pa ogledali proces 3D tiskanja in to iz Form 3BL. Še naslednji. Evo, takole. Se pravi, korake imamo 3. Prvo je seveda oblikovanje vašega 3D modela ter pripravo v Preformu za tiskanje. Drugi korak je samo 3D tiskanje, se pravi, kako pripravimo tiskalnik, kaj potrebuje, da lahko začnemo z našim tiskom, ter po tiskanju pa treba še te kose natisane postprocesirati. Ta tehnologija vedno zahteva, da se kose operajo v izopropilnem alkoholu, da se znebimo starenega materiala, ter še dodatno utrjevanje v UV pečici, da pridemo do teh želenih materialnih lastnosti. No, zdajle bomo pa si ogledali, bom delil jaz tukaj program. Evo, tukaj zdaj se nahajamo v programu Preform za pripravo modelov za tiskanje in v bistvu že imamo izbran kar tiskalnik Form 3BL. In kar v bistvu, ko vozimo naš STL model, mi imamo možnost ga orientirati po želji, sicer znotraj nekaj parametrov, nekaj vodil ustrezne orientacije, ter kar lahko naredimo tukaj na levi, izberemo, da nam tudi program samo predlaga orientacijo. da nam program tudi samodejno generira podpore. To v bistvu izgleda takole. Imamo podpore narejene. Ter seveda na koncu nam samo še ostane tudi postavitev po naši delovni platformi. Tako da tole v spodaj, kar v bistvu vidimo, je delovna platforma, ti lahko pokažem. Izgleda takole, ko bomo tudi kasneje vstavili v tiskalnik. In v bistvu na temle se tiskajo naši kosi, kakor vidimo na programu. No, in kako imamo mi naše modele ustrezno orientirane, pripravljene s podporami, z ustreznim materialom. Gremo klele pod tole oranžno ikonco, izberemo naš tiskalnik in naložimo na tiskalnik ter to je to, kar se tiče dela s tem programom pri Form. V redu, zdaj pa bom... V redu, zdaj pa program naloga je naložena na tiskalnik. Zdaj, kar nam zdaj ostane, je, da pripravimo tiskalnik in za pripravo pa v bistvu potrebuje 3 elemente. Prvi element je rezervoar oziroma resin tank. Tukaj notraj se dozira material in iz tukaj se ven tiskajo naši kosi. Se pravi, od spodaj enota iz UV laserjem utrjuje material, ki na drugi strani, se pravi tukaj, in se potem to vsak sloj raste tukaj iz tega ven. Kar bomo mi naredili zdaj, bomo odprli in enostavno kleli na taka vodila vstavimo gor rezervoar in ga potisnemo do konca. Imajo pa ti elementi vsi tudi senzore, tako da je zaznal, kjer rezervoar sem ustavil, ter tudi kjer material je notri. Trenutno mi javi, da ni nobenega, ker je tudi prazen. Se pravi, tu imamo ustavljeno. Naslednji element, kot sem že pokazal, je pa delovna platforma. Tole imate eno zavedno, je aluminijasta in ni potrošen material. Če recimo za primerjavo od Form 3B, je od Form 3B se vidi, da kar bistveno večja platforma, tako da lahko več ali damo več manjših kosov lahko gor ali pa manj večjih. Tako da tole stavimo tukaj gor, ter zapremo. Tako da 2 elementa imamo že vstavljena, zdaj nam ostane samo še eden, to je pa material. Material sem omenil je v obliki kartuš. Za delovanje s Form 3BL tiskalnikom sta vedno potrebne 2 kartuši istega materiala in to postavimo tukaj v temu namenjena mesta, tukaj ob strani. In vsak material, vsaka kartuša ima svoj čip, svoj senzor, svoj čip in ga tiskalnik vsak material zazna. Tako da to si lahko tukaj ogledamo in tudi nam pokaže, koliko materijala je še v kartušah, tako da lahko predvidimo, ali bomo rabili malo zamenjati ali pa ne, ali pa kasneje. Tako da to je, kar se tiče priprave tiskalnika, potem enostavno gremo samo tukaj v našo čakalno vrsto, kjer smo naše printe naložili in samo stisnemo print in tiskalnik bo opravil vse ostalo svoje, da bo tisk uspešno izveden. Se pravi, bo preveril optiko, bo preveril, če so ta pravi materiali, bo preveril, če je tiskalnik ustrezno niveliran, ter nas na to opozoril, če karkoli manjka, če treba čemu posvetiti pozornost in to je v bistvu to. Stisnemo tukaj samo na zaslonu print in se bo tisk začel. In bomo zato tudi obveščeni na telefon ali naš e-mail, da se je print začel, tudi vmes, kako poteka, ter tudi, ko se je začel. Tako da imamo celotno kontrolo, smo konstantno ozaveščeni, kaj se dogaja. Tako da po samem tisku nam pa ostane samo še postprocesiranje. Postprocesiranje, kot sem omenil, se izvede najprej sprva v izopropilnem alkoholu, se opere, da se znebimo nestajenega materiala. Zatem počakamo, da se posuši. Ko se pa posušijo kosi, jih pa damo utrditi v UV pečico, kjer dobimo te maksimalne lastnosti. Tako da zato pa Formlabs ponuja rešitev v obliki Form Wash in Form Cure, tako da ta postopek bistveno pospeši in nam zelo olajša. Tako da to je v bistvu to, kar se tiče priprave, mislim same izvedbe, tudi tiskanja iz Formlabs tiskalniki, tako da postopek je zelo enostaven in je uporabniku tako zelo prijazen. Tako da to je to z moje strani.
Ok, hvala Rok. Sedaj pa bomo besedo predali nazaj Milošu, ki nam bo povedal, kako se uporabljajo, torej nam bo predstavil materiali in aplikacije, v katerih se te uporabljajo, in razložil nam bo tudi, kako Formlabs sodeluje v boju proti koronavirusu. Torej, Miloš, predal sem ti kontrolo, če lahko.
Hvala. Okay, thanks. So we have a bit more time. I will try to not run through the slides, but to speed up at least. Okay. Good. You mentioned, so regarding materials, I don't want to focus too much on that because two things, it requires a separate webinar and just discussion just over the materials, what we have, their specific applications individually. But let's say that for us, that the materials library is something that is constantly growing. It is one of our top priorities. Besides of making good quality printers, we even purchased and we created our own factory that produced the materials, just so we can be in the full control over this, and we basically guaranteed the fantastic printing experience and process, and we guaranteed for the end results in a way. But okay, so first things first, we wanted to say a few things about application. I gathered something that I think could be interesting, and to try to touch base on several applications and different categories in a way. We will have, as Rok mentioned at the beginning, we can make separate appointments, let's say one-on-one, where we can go to any kind of specific application that you're interested if you want to know more, and we talk specifically regarding what you're doing and how we can help. So pardon me if I don't touch base on everything, but it's a bit time constraint for us. But in short, so what we are doing and where we are present, in a way, we can split it into clinical, educational, and supply chain. Mostly I would like to focus on clinical today, pre-surgical planning, guides, implants, but we'll touch base a bit on everything. And as Rok mentioned as well, the fighting against COVID, which is majority of nasal swabs. But okay, sorry, this is not showing the best format, but nevertheless, patient-specific pre-surgery is, let's say, now the main focus, and what we are doing and what our customers are doing in majority. So surgical guides, planning, fixation trays, but also a bit of educational and prototyping applications. So in a way, if you plan better, the results are better, and it's in a way no-brainer, because what you're gaining with producing models with additive way of additive manufacturing in a way. So you get better preoperative planning, better preoperative simulation, device and implant sizing, which is increasingly bigger topic, not only for us, but for everybody because it's one of the biggest places where you can have the price reduction, which everybody likes, but also for me personally, improved training, patient experience and education of patients. For someone who was on the reciprocating end of it, it brings more peace if you have a specific model to show to the customer and go through it, because not everybody is thinking in three-dimensional and can imagine stuff. So yeah, every bit helps. And just wanted to put, it's the same model as previous. So the spinal scoliosis, but this was done in 6 Form 2 printers that produced 6 parts that were joined together 36 hours, you will see later on. I didn't have time to put it into preform, sadly, but now with 3L, basically we can put entire model into one machine, and you can have it, especially if you're using, now back to the topic of materials. One, we are really keen on having great materials, but 2, what is really important to have those materials exactly the same as the CAD model, because it has to match and replicate, so the accuracy has to be there. But the third factor is also the speed. Now we have the new material named Draft V2, and with that, instead of, 36 hours, we can go to roughly around 9 hours. So you can create one model basically day in, day out, and tomorrow morning you can have it prepared. And for this intricate like scoliosis like this, this is really a game changer in a way. Okay, we have time. A few more examples of producing this type of educational models printed, but this is a standard gray resin, I would say. Okay, and then to touch base more, it's not only about rigid materials. We also have several elastic or flexible materials as we call them. And one of the biggest applications, I don't know if this will, no. Okay. Rock, can you help me and get back to the presentation, please? Thanks. Okay. So sadly, it's not working, but this is elastic material that replicate the veins and arteries. So it's really good for training purposes, simulations, but also for validation of any kind of pre-plan, surgical planning. Okay. And now to the bit of more of the heavy stuff. So I highlighted a couple of examples, but this one, I think it's best to highlight not only the Formlabs or models, but where we are in a digital world. So this is ameloblastoma. It's a rare kind, basically, of tumor that starts in the jaw, most often in molaris or the wisdom teeth near that. And basically, how do you approach that? So you have the scans, radiological images and data, and you convert them. We are working with actual 3D and several others, let's say, big players in the market. So any other software that you can use to get that data and convert them to raw STL files will work here, by the way. And yeah, okay. So you make scans, you have the data, and you convert them, and you start your preparative planning. So you go into digital osteotomy. So placement, you find way to cut, how to cut it, and how to approach it, because it's not really as easy peasy. And you dissect the tumor, you see the bones surrounding the tumor, and then the biggest thing is, how do you do the reconstruction of that? So mandibular reconstruction, in this case, you have the fibula, which is the small backbone that you have, and I'm a mechanical engineer. I have to remove myself from the equation if I say something that is not correct, and I don't pretend to be a doctor in any case, like a small asterisk above my head. But still as a mechanical engineer, this is something that I was pushed into and can grasp as a concept. And I like the fact that we're approaching this as a spare part, as a part of fibula, so I can understand it quite better. But yeah, you have the part of the bone, and so surgeons digitally dissect it, remove the tumor, and choose which part of the bone basically they're going to reconstruct in a way. And after that, this is where the 3D printing kicks in. So from here, you create the patient-specific surgical cutting guide. This one is done with SG material. So it's a biocompatible material that after the UV curing is placed into autoclave and prior to surgery. So it's something that is really used in the OR. And you continue with that. So we have the cutting plane, we have everything, you go into the surgery, and then after that, my controls are, okay. So once that is done, you have the reconstruction made, the plane, and you can finish with creating the orbital plane, maxillary plane plate here that is shown. So just briefly, I don't have time to go. This is, for me, usually 30 minutes discussion. I don't have that commodity here, and so I'm apologies for that. Similar thing, same material, but just wanted to highlight because for me it's a better picture to show. It's a same SG material, similar application as well. But in the end of the day, this is something that it takes, I would say, 20 minutes to make. And roughly the cost for it, it's not bigger than 15 euros. And this is part from Mayo Clinics from the US. And also, side note, what they're doing also when they scan the tumor and when they remove it, they do the scanning again. So they're creating a digital library that they're putting for educational purposes, that it's not only weighted and it's stays someone in the basement in formalin, but it's a digital library that they use for every kind of educational purposes, but also to trace back to specific patients and to track the development in a way. And yeah, okay, same material, but just diversity of application. This is for the spinal drill guide. I made a promise to the guys I will not show any bloody pictures, so I'm this is the polished version. And now, as we mentioned for the one of the first examples, so when you have to dissect the bone, you need a surgical guide for that. So these are the real life examples of that, and the picture on the right here is basically a mixture of educational, because for me it's a blurry line. What is educational, what is pre-surgical planning, because in the end it falls into the same place. And this is basically it. So you have a tumor, but you have to see how to approach it, how to tackle it, but also you need to make a surgical guide and plan accordingly. And I think this allows you for the most precise version of that. Okay. Second section, surgical planning, but this is more of the patient-specific prototyping in a way. This is for the prostate tumor for a kidney transplant. But in a way, besides for someone who is not familiar, it looks quite nice and colorful, but it really allows for a proper pre-surgical planning and what to do. And as I mentioned on the beginning, to put a bit of the ease of mind on the patient side, because for them, if they can see something, they can understand and grasp it more better. And just a few examples. Again, my video is not working for this, I think, as well. But with variety of materials, with coloring options, with having the ability to print materials that mimics the veins, the skin, the bone, basically you can really make almost one-on-one situation that is happening. So it cuts the surgical time as well, which is at the it's the end game in a way. Fourth one, coming to an end. Don't worry, Rock, I will be on time. So when we talk about prototyping, it's not only how to make certain stuff, but it's really for instruments and kits. And we are doing this with a lot of hospitals globally and trying to figure out the best way to plan it and to do it. Implementation, implant components, orthopedic cuts, drill guides, and so on. So it's really the variety of those. And as mentioned, sadly not enough time to go into all of that in details, but I'm more than happy to have a one-on-one conversation for that. And just for the end of this, really two, for me, good examples that highlights where we are at in the 3D printing world in the moment. This is our Turkish partner, Bilkotek, and yeah, this is the serial worm victim. But in a way, there is a light in the end of the tunnel. So the surgeons were able to gain, let's say, a second chance to the patient, and at the end of the day, this is what for us makes the most of the difference. And for something that is not all over the globe, I think, yeah, this is working. And basically, this is your neighborhood.
Nick was born 1 month before due date. Because of difficulties during the birth, he suffered severe brain damage. When we left the hospital, the staff there said that we will be happy if Nick ever sit by himself.
When he was trying to walk, it was really hard for him. His feet was really in bad position. If he will walk longer in this position, he will injure the bones and joints.
Nick conditions, it's that overpronation, that going mid-arch is going too much in because his muscles are too soft.
Petra has a lot of patients that overgrow their orthosis. Almost every solution that she showed me needed to be corrected after the first design. It's not comfortable, it causes skin irritation. The patients cannot use their right shoe size. When she finally says also the price of the suggested solution, I was okay, this is not right. She always tried to push similar products into one box, and I didn't want that my son is in one of the boxes. I didn't have the solution at that time. I just knew that I can do better. If you need to create something for yourself, I don't think there is a second option to 3D printing currently. When he put the orthosis on, it was, oh, I feel comfortable, I feel stabilized, I feel confident. And it was, 2-3 days and he was walking.
After 4 or 5 months he wearing it, he started to be faster and faster. He actually started to dance.
Currently he's using his 4th different version of orthosis. If he continues to improve like that, I think the 5th one will not be needed anymore.
3D printing, you can say here it's 4 millimeters and here it's 1.75 millimeters. In terms of mechanics, this is great news. In the moment we are testing with several patients with different pathologies, with quite different age.
The current industry is, still built upon 50-year-old technology. Somebody needs to make a new pathway to present an alternative. An orthosis should be built for a person. I really see this taking off because it has so many advantages that you cannot just push this technology on the side. You have to embrace it.
I'm muted. I think this was way better than me speaking about it, and I rather usually speak about the local content in that way and what people are doing really around us, than to say what a random company in US is doing with any kind of our materials. I think it speaks quite better in a way. Not again. Okay. Closing up, just to touch base on a few things as well. I mentioned at the beginning that one of the main driving forces for us in creating the materials and new printers, new machines, is the feedback that we get from the community, from the people that are really using the printers. And the COVID situation that is sadly here to stay really changed that in a way, and kind of pushed us more into a healthcare problem. And Formlabs in a way also wanted to see what we can do to help. At the beginning of the global pandemic, so there was not much. You had a few things that you can do with the shields, and then it really kicked in. So we converted we have a print farm all over the world, several of them, that produces usually the sample parts. And we say, okay, we want to help. And then the nasal swab thing came along. So it's made by a biocompatible material, the clear one in this case. And what we can do, we just expanded. So in a day, we were able to produce over 100,000 nasal swabs, which for us, it still wasn't enough. But in the midst of global pandemic, where you don't have it enough, and when it's needed, that's a great thing about 3D printing in a way. So you can really shift, take a pivot. If something is needed, you find a way and you make it happen. But we also, converted then in the following weeks to various stuff. So ventilator splits, beep-up adapters, emergency diagnostic kits, visors, and the adapters for scuba dives. But I just wanted to touch base on nasal swabs because now they're the most in-demand thing. We're working with several hospitals in Europe, in US, Asia Pacific now as well. We're trying to make as much as possible of those and to ship it globally. But in a way, the process is similar as any other biocompatible material. It doesn't matter. So you print it, you have to wash it in isopropyl alcohol, you have to cure it for a amount of time, sterilize it, pack it, sterilize it, and then use it to the shortest. And I would just like to, end here in a way, because I think we're running out of time. Rock, you can take over and announce what is coming next, and we're available for Q&A as mentioned, and one-on-one meetings. And thanks for your time. Appreciate that.
Okay. Hvala, Miloš. Torej, kot je Miloš že napovedal, pa kot sem jaz tudi povedal na začetku samega webinarja, naj vas še enkrat opomnim, da se nam lahko pridružite na virtualnih sestankih. Torej, to so sestanki med vami in predstavnikoma podjetja Formlabs in IB-CADDY. Zdaj, na teh sestankih lahko vprašate karkoli želite. Torej, lahko predebatiramo različne strani 3D tiskanja, materialov, karkoli vas torej zanima. Torej, prijavite se lahko na tej povezavi, ki je vidna na tem slajdu, torej www.ibcaddy.com/formlabs-virtualni-sestanek. Skratka, tam se prijavite. Torej, mi bomo stopili v stik z vami, uskladili termin in dobili boste povezavo na sestanek, zelo podobno kot ste dobili povezavo na ta webinar in torej, kot v tistem terminu bomo seveda naredili sestanek. Rad bi se pa seveda zahvalil tudi Milošu. Miloš, thank you for attending and helping us with this webinar. Vsem skupaj pa želim lep dan in nasvidenje.